Hi viewers, this is Dr. Gunamani Jana and you are welcome to our machine learning series. We already covered a number of algorithms under this supervised learning. Specifically, if you see the diagram here, the chart, we covered the supervised learning, the number of algorithms, especially we covered the supervised learning. First one, we have gone for this regression, under which we have gone for the simple linear regression, multiple linear regression, then polynomial regression, then we covered the decision tree, random forest, then we covered the KNN, K nearest neighbor, then we covered the logistic regression, naive Bayes as well as the SVM. So these are the things already covered under the supervised learning. So in this video we are going for this unsupervised learning and mainly we are going for the k-means, and as you can understand it is mainly a clustering type of algorithm, right? So that means making them converting into a group based on some similarities. So this is the thing. Now how do we implement all the things directly? I'll go for the implementation. If you see here, I have the data set what I am using it here, that is mail customers.csv. What is the meaning of this here? So I have a database where I have the data like the different customers, customer ID, their gender, male or female, their age group, their annual income in $1,000, and the spending score, it is 1 to 100, like that. That is the score is 100 or it is 1, like that we go for that one. So this is the data, and in this if you see this that we have to import some libraries like import numpy as np, import pandas as pd. So you control enter or shift enter, so it will run and all these things will library will imported. Then I created a data frame df which is equal to pd.read_csv. so this is the data I have taken from this kaggle.com. so that is mail_csv, mail_customers.csv. This is already there. Already I will show you the data already, the data frame, data set, it is already there. Then if I try to see the first 5 lines of the data, then exploring the data set, I use df.head because this pd.read_csv of this data set is stored in df. Okay, so to access this data set I have to access this df, right? So df.head, this method it explores the first 5 lines of the data. So here you sign 0 to 4, that is in 5 numbers, then customer ID 1 to 5, then the gender, actually it is by mistake written gender, G-E-N-A, gender, not like you write, you treat it as gender. So whenever G-E-N-E-R is that, we treat it as gender, right? We can in the data set also you can change it gender, so we can use gender. Now this male, female, all things will be there. Then what is the age group of these people? Because in this 5 data we are having age group 19 to 31. Then what is the annual income in $1,000, $15,000 or $16,000 or $17,000, like that. It is in $1,000. K stand for 1,000 and dollar sign is there, you can clearly understand. The spending score, it is given in the range 1 to 100. So how many times is purchasing and whatever the amount is purchasing, based on that the score is decided, right? So we have the data set and we represented all things. So if you want to see the number of rows and columns, then we can use the dot shape method, df.shape. So it is showing 200 rows and 5 number of columns are there. So 1 2 3 4 5 you can see it here. So this is not important. The customer ID 1, gender 2, age 3, annual income 4, and the spending score, that is 5. Then if I want to find the columns, so df.columns, first it is coming the customer ID, then is the gender, then is the age, then the annual income, then the spending score. All things are coming, and you type is the object, data type is the object, right? Then if you try to find or explore df.data types, so you find the gender is object, customer ID is integer 64, age is integer 64, except the gender, because gender is only the characters you are using, it is male, female, like that, or remaining all are integer, right? Then df.head, so if you try to do it here, now the same thing we find it here. So now first 5 rows of data it is given there. Then df.tel last 5 up, you see it is coming from 195 to 199 because it is starting from 0 to 199, around 200 rows are there. So here also you see the same data. Then if you want to get the information regarding this data, then df.info method, you use it here. Here you can find what is the customer ID. There are 200, there is no null, and gender also 200. That means all the data are there, right? So df.information, so all the data are there. Or df.describe, you can put it here, how many counts are there of the customer ID. 200 count are there, and age is also 200, and annual income. That means all the data is there, no data is missing. So what is the mean you can get of all the things. Then what is the standard deviation, what is the minimum, what is the 20%, 50%, all the things we can calculate using this df.describe .t, right? So now, so if any null value is there, so df.isNull .any method, you use it here. So false means there is no null value here. If anything, because this is used for the pre-processing, then you go for the data cleaning, because some things we are going to predict and the remaining is the predictor. Like I put it that df dot copy, that is deep is equal to true, and here the same thing you put it at df underscore copy, right? So the df underscore copy dot head, what you are writing, you are getting customer ID, gender, age, annual income, and all things you are getting it right. Okay, so you have copied some part of the data here. Fine. Now from this I want to drop say customer ID. Customer ID is not important for me. So then how do we copy df underscore copy? Because I don't want to work on the original data set, just I am copying the data, df underscore copy dot drop customer ID, axis is equal to 1 and in place is equal to true. Then if you see the df underscore copy dot column, customer ID is not there, so it is coming gender, age, annual income, spending score, all things, and data type is object. Okay, now if you go for the data visualization, then we have to use the matplotlib. So for that we need to import these libraries. So import matplotlib.pyplot as plt and import cburn as sns. So all the things by default it is there, you can go for this thing. Then if you try to find the df underscore copy dot columns, already we previously seen, same thing we see the index is like this, gender, age, annual income, spending score, and data type is object. So if I want to plot, so gender plot, how many male, how many female are there, so sns dot count plot, so x axis is equal to gender, and y axis you are saying data is equal to df underscore copy, right? So it will count how many male are there, how many female there. So x axis it will say the gender, male and female, and y axis it will count how many are there, right? Then what you do, plot plt, that is the plotting plt dot x label I am putting gender, I am writing it here, and y label I am writing plt dot y label, which is equal to count. Okay, so here I am writing first blue color, it is coming male, and this something brown color, it is coming female, and you can count here at around 90 males are there, and around 110 so female are there, because total it is 200 is there. So exactly I do not know, it is 90 or 85, something like that, it will be 115. So this is the thing, we got it there, right? Then suppose I want to go for age plot, then how you go for that one? So plt dot, I am going for the histogram. So x is equal to df underscore copy, I want to put the age. Okay, then beans is equal to 9, and orientation is vertical, and color is equal to red. So color of the graph is usually red, and vertical is there, if you can horizontal. Okay, so these are things you do it here, and plot plt dot x label age, and y label is count, and plt show. So now the histogram you can see, age plot observation you can see it here. That means with the age group of 20, around 30 people are there, with the age group of 30, so all the things with this we can age group of 60, this much of people are there, age group of 70, this much people are there, right? Now age versus spending score. So according to the age, what is the spending score? That is the spending score we have given 1 to 100, right? So some people they spend lot of money, because in proportion to their income, they almost all the money they spend, and sometimes they borrow money also they spend, because according to the requirement, but some other people they only try to spend 40 to 50% of the earning. Remaining they want to go for a no. They keep it in the bank. I get it now. So now what I am going to do, I am going to calculate or plot age versus spending score. How do you do all the things? SNS dot scatter plot. So data which is equal to df underscore copy, and x is equal to age, y is equal to spending score, the range is equal to 1 to 100. Okay, and what I am doing, because this is the thing that I have to this, then hue is equal to gender, and SNS joint plot data is equal to df underscore copy, x is equal to age, y is equal to spending score 1 to 100. Okay, so with all things, because two ages, two different type of genders are there. One is the male and female. So your male is represented by the blue color and female is represented by the brown color. So if you check it here, according to the age, the spending score is already plotted here. That means if I say here, the people with the age of 40, they usually spend around 15,000 or 18,000. Like you can see it here, this is the thing. Like that, the 70, these are things are there, right? So similarly, suppose if you want to plot here, then you can clearly see here also what are the things you have given it as you plotted here, all the things. Then this x-axis here according to the age, and here according to the score, all this data is plotted in both x-axis and y-axis, right? So age versus spending score observation. So from the age versus spending score, we observe that customers whose spending score is more than 65 have their age in the age group of 15 to 42. You see, so this is the highest spending, is not it? This is for the spending, because this is the y-axis spending, and this spending, if you map it here, it is coming 40 to 50. This age group they are only coming. Same thing with the observation. Okay, so highest number of spending group, the age in the 15 to 42, like that it is coming. Okay, these people are coming here, right? So also from the scatter plot, it is observed that customers whose spending score is more than 65 consist of more females than male. See, more than 65. See, spending is more than 65. You see, spending is 65. It is here 60 to 65. You see, here it is dominating by the red color. That means the brown color. That is more number of female at this age they are purchasing. Right, spending. These are the observations, you can get it here from this graph. Then finally we are going for this annual income versus spending score. In this score, what you do, SNS dot scatter plot data is equal to df underscore copy, x is equal to annual income, and y is the spending score, and hue is equal to gender, and SNS joint plot. All things I try to do it here. Again the same plotting what you have done previously. This is also one more type, it is plotted here, and the same thing also we are able to plot it, annual income versus the spending score, and we, in addition to that also we plotted, and here we can say this is the group, this is the age group where the maximum spending is done, right? Up to this it is okay. Now annual income versus spending score observation, we find 5 category of people are there. Okay, what are they? High income, high spending score, that is the top right cluster, and high income, low spending, that is the bottom right cluster. Then average income, average spending, that is the center cluster, and low income, high spending, and low income, low spending. So these are the A, B, C, D, 5 number of different clusters are there. So some people they belong to high income and high spending, some people they belong to high income and low spending, like that you can do it all the things, right? Now selecting the annual income and spending score as the feature for clustering, how do you define Ax is equal to df underscore copy dot I location. So this is column 2 to 3. Okay, so now using all the things I can find what is the x column. X column it is coming annual income and the spending, so these two things are coming. So now finding the optimal number of clusters using elbow method, how you do all things. From sklearn dot cluster import came in, so WCSS which is equal to this one, and for I is equal to in the range 1 to 11, a k-mean model which is equal to k-mean of n cluster which is equal to I, comma, init is equal to k-mean plus plus, then a random state is equal to 42, and k-mean model dot fit x. What is the data we have taken? X we defined that we fit to this k-mean model, and wcss dot append k-mean model inertia. So if you run this program, okay, in some it is running, there is no problem on the because it will not plot anything here. So if you are going to plot, so plt dot plot range 1 to 11 wcss, and plot title is equal to elbow method, plot x label is the number of clusters, plot y label is the wcss, and plot. So once you show this one, you can clearly say the number of clusters are there here, and wcss is also it is shown here in this y-axis, right? Now while you are going for this feature scaling, for the feature scaling, so we understand that 5 number of clusters ever clusters are optimal for the given data sets, that we understood. Okay, 1 2 3 4 5 number of data that we have taken cluster. Now for the feature scaling, from sklearn dot preprocessing import standard scalar, then scalar is equal to standard scalar method, and x is equal to scalar dot fit transform. So this feature scaling is performed because k-mean uses the distance, Euclidean distance. Okay, because it is entirely based on you decide a cluster center, and what are the data points, you find what is the distance between them, and who are nearer to that one, they belong to that cluster. That is the main, that is based on the Euclidean distance. What is that? That is that x2 minus x1 whole square plus y2 minus y1 whole square and square root. This is, as you know, Euclidean distance. Then coming to the model building, then you do this one in this model building. So k-means underscore model, that is equal to k-means n cluster, that is number is equal to 5, init is equal to k-means plus plus, random state is equal to 42, and y underscore k-mean which is equal to k-mean underscore model dot fit predict x. Okay, so from this x we want to calculate the y, that means it belongs to which group, which cluster, it will tell you, right? Now so this is done, some warning it is showing, don't worry for that warning. Then while you are going for finally using the clusters, now you can see it here, this you can see here. So for the visualizing the clusters, so use the plt dot scatter. So x of y k-means which is equal to 0.0, here I am telling s is equal to 30, and C color is equal to yellow, and label is equal to cluster 1, right? So what yellow is the cluster 1. Where is the yellow? So this is the cluster 1. Got it now? Similarly, cyan, that is the cluster 2. Cyan is the cluster 2. What is the cyan? This is the cyan. Okay, this is the cluster 2, right? Similarly, 3 is the light green, that is cluster 3. So you can see this is the light green, it is cluster 3. Similarly, orange cluster 4, orange is cluster 4, and something red is cluster 5. That means cluster 1 2 3 4 and 5, right? So it is all the cluster, this legend it is already shown, and the plus mark is the cluster centers. So this is the center for this cluster, this is the center for this cluster, this is the center for this cluster, this is the center for this cluster. Now whenever you add any new point here, then using this model, it will predict it belong to which cluster. That is the main purpose of all things, right? So now from this you can clearly understand that high income and high spending score, that is a cluster 5. So these are the group who are high income and high spending. Like that, what is cluster 3? What is the cluster 3? Because 1 2 3, this is the cluster 2, this is what is cluster 3? Cluster 3, high income and low spending. This is high income, high spending, this is high income, low spending. Like that you can find all the things: low income, low spending, low income, high spending, and average income, average spending. So all the things we can get it there. I hope you got a minimum idea how to implement this k-mean algorithm. So if you need the theory part also, we can make one more video where I will be explaining with a PowerPoint presentations what exactly and how this cluster is working. Thank you for watching this video. If you like this video, please do share with your friends, and also don't forget to subscribe. Thank you. Thank you once again for watching this video. Bye.